Yep. All right, so what was the main rule that we've talked about all along about multiplying? What can I multiply together?
Anything.
Anything, right? That's a really important concept again. So you got to remember that. But today we're basically going to multiply fractions, or we could say we're going to multiply monomials also. So we're going to multiply or divide monomials or fractions. What are monomials?
Product, variable, or number.
Product, a variable, or a number. So again, it's just another fancy way of saying a term, right? So basically what you have to remember is that I can multiply anything together. To show that I'm going to multiply a number and a variable together, what do? Just put them together, right? Just put them together. So, this is still true. The thing that we have to worry about now is in monomials, we're going to have problems that include exponents now. All right, so it was a number or a variable or a product. Well, we can have multiple letters also. So as Carson said, if I had 2 times x, then we get 2x. So if we have a number and a variable, we just put them together. But if I have a variable times another variable, I can also just put them together, right? Well, the same thing happens if I have a variable times another variable, but that second variable has an exponent on it. Because I have a cow and a horse, I just put them together again, and I bring my exponent along with it. So the concept that we're going to talk about a lot today then is what happens if I have a variable that has an exponent times the same variable but with a different exponent. Okay? So again, this rule that we're going to talk about is only true, let's make it a star here. So we're going to look at multiplying exponents with the same base. Because what's the base of an exponent? What was the base called? Or what portion of my exponent is the base?
Like the number, like x,
In this example, what's my base?
x.
X, right? So the bigger part, right? So we're thinking about the base is being multiplied to itself the exponent number of times, correct? Okay, so remember now, in this case right here, what does x squared or x to the 4th really mean? What does x squared mean?
X times itself.
X times x, right? And x to the 4th really means what? 4 times, right? So we could realistically just write them all out and then count them all up and see what our answer is, right? I mean, that's one way you could do it, but who would really want to do that if this was x to the 20th and x to the 72nd? I don't want to list all those x's, right? And then count them up and see how many I got, right? So anytime that you're multiplying exponents with the same base, we are going to add the exponents together. And then use the base. So one way, if we did this problem right here, and we had x squared times x to the 4th, another way of writing this is saying I'm going to take those exponents and add them together. So x, and then 2 plus 4 gets me x to the what? 6th. So this is going to be true every single time that my base is the same. If the bases are different, we just put them together like we've been doing all along. But if the bases are the same, we're going to add them together. That makes sense? Now, you might have to do multiple variables in one problem. So there could be some x's, there could be some y's, there could be some z's. You might have 3 or 4 different variables, but that's okay too. And then, don't forget, so this only applies to our exponents, and then obviously you multiply the coefficients together as normal. So if there's numbers, you just multiply the numbers as we would normally do. And then we're looking at individual bases and combining the bases into particular numbers. But we're going to add them together. So, for instance, we can do this with numbers also. So if I have 3 to the 4th times, I can't read it, 6, 3 to the 6th. So even though that we now have a number as our base, we can apply the rule that we just talked about. Okay? Because they have the same base, I can take and add up my exponents, so really I would get 3 to the what? 10th, right? Everybody agree? Now, here's the key, and this is kind of me more than anything, but kind of a star here. If you can figure it out, or as we said yesterday, if you can simplify, we want you to solve. So, this would be where I would want to use my calculator, because I don't think any of us want to do 3 times 3 times 3 times 3, because it'd be a really ginormous number, right? So if somebody's got a calculator, somebody punch in 3 to the 10th into your calculator. It doesn't have what?
Got it. Yep.
59,049.
49.
Okay. What do you mean it doesn't have? Your calculator doesn't?
Yeah, it's not just square bottom.
Okay. Then you want to probably get a little better calculator. I'm sure Alyssa or Josie has an extra one at home. Okay? But does that make sense? Remember, can I really simplify this anymore? The only way I can simplify this is if they told me what x is, right? So if there's numbers in the problem, I'm going to simplify. If not, I'm just going to leave it alone. So, solve and simplify. 9 cubed times 9 to the 12th. What do you get? 9 to the 15th. So if you don't have a calculator, I guess you're kind of up a creek. If you do have a calculator, what do we got?
Holy shit.
2.058911.
Hold up, say it again.
Here.
2.05891132 to the 14th.
To the 14th?
I have a
To
little.
the 10th, I got.
Okay, this is what my
Yeah. So to the 14th. So here's a good example. Those of you that don't have a calculator, see this little thing over here in the corner? Okay? Does everybody else see on your calculator? So if you didn't do it, punch it into your calculator again. See the little number over here towards the side? This is called, we'll learn about this in a little bit, scientific notation, but that means there's 14 more places over here. So there's 14 more zeros on that number, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have no idea even what that number is probably called, right? There's probably some name for it, but holy moly, right? Then we'd come back and, right? So, if somebody is bored in study hall, look that number up today. All right? And we'll come back and we'll talk about it. Okay with that though? Understand what the numbers? How about this one right here? What do we get if we do this? Y to the 4th times y. What is the exponent of the second y? 1, right? So if there's nothing there, remember it's always 1, so this turns out to be y to the what?
Fifth.
5th. Okay? Everybody good with that? Now remember, what are ways for us to show multiplication besides putting them together? I could use a dot, right? What else?
Multiplication, like symbol.
Yeah, okay, some of you were still using that the other day when we did the factors. Try to not use that anymore because it really looked like variables for some of you. So try avoiding that. And what's my last way? What's another really important way to remember? Using parentheses, right? Using parentheses, okay? So, here we go. Negative 3x squared times 4x cubed. So again, we throw something else in there, right? Now we throw in positives and negatives. So what was our rule for multiplying and our signs for our answers? Exactly right. If my signs are the same, it's positive. If my signs are different, it's negative. So, again, in this problem right here, I'm going to do the numbers like we would normally. Multiply the coefficients as normal. So what's negative 3 times 4?
Negative 12.
Negative 12, and then for my x's, I'd have x to the 5th because I'm adding them together again, right? So this is, the only real complicated part of this is kind of remembering that I'm kind of going back and forth between multiplication and addition, and vice versa. Okay? Yes?
So what's the 9 third? Why don't you times the 9 and the 9? You do it up there.
Say it one more time.
So for that one, you didn't times the 9s, but that one, for the 3x, and then the 4, you did times.
Because these numbers are acting as a base of an exponent. These numbers are just numbers. I think that's what you're asking, right? Okay, so that's a good question. So he's saying, why did I take 9 times 9 and then do it? Well, these 9s are acting as the true base, so I'm taking 9 times itself 3 times before I can do my multiplication. So this 9 isn't, yeah, it's a number, but it's not the true number in the problem. Good question. Okay. How about this one? I don't know what this is supposed to be. 3p to the 4th with parentheses all around there. And then negative 2p cubed. Is this right here any different than the last one? Basically how we wrote it? Not really, right? I just used another set of parentheses. Okay? But realize this, before you try to do this problem. The 4 in this part right here is only to what part of the problem?
The variable.
To the variable, right? It's not to the number. If you wanted it to the number, then we'd have to put it in a different spot, and we just haven't gotten there yet. Okay? So, go ahead. What'd you get?
Negative 6p7.
Awesome. Piece of cake, right? Any questions on any of that? You want to see any more examples of those kind? Okay, so if we can multiply fractions or monomials, we should probably be able to divide. So we're going to try to divide monomials, and this is where we're going to include our fractions, right? So again, basically the same rules apply. I can divide anything together. The signs are just like what Addison told us earlier, right? If they're, the numbers or variables are different, it's always negative. If they're the same, it's positive. Okay, so those rules are still the same. The numbers again, so for the coefficients, the first thing that I would try to do is just divide. Can I take the numbers that they give me and divide? Like in the first example that we had for the bell ringer, it was 16 divided by 8. Go ahead and just do your division. So if you can divide, divide. The second thing that I'm going to try to do is simply reduce, right? Or simplify. So this is what we did for our assignment today. Again, if you have to go through that process of doing the prime factorization or filling out those factors, that's what I'm going to try to do. But I'm going to try to simplify the numbers. I'm just talking about the numbers now, right? The coefficients. And again, I might have to do it more than one time. If I have bigger numbers and I start out just using 2 because I recognize that they're both even, I might have to do it more than one time. Okay, so this part right here is exactly what we did for today. Now we're going to talk about the variables. And what did we do with the variables for today? We basically just what? Eliminated the same number on top and on the bottom. Basically, we're going to do the same thing. So we really did what we were doing for today yesterday. When we did the simplifying, it's basically dividing monomials. Now, if that confused you, another way you can think about this for the variables with the same base is if I had x to the 7th over x to the 4th. So yesterday we talked about just eliminating the same number of x's on the top as we do on the bottom. We just kind of crossed them out, right? Well, if that confused you, we can have a rule that says we take the exponents as long as they have the same base and we subtract the exponents. So like when we were over here, we had the same base and we were multiplying, we added. Over here, if we have the same base but we're dividing, we're going to subtract. Now, this is a great rule to follow, like this rule, but there's some confusions to this rule. And to me, what we did yesterday by eliminating just the same number both on the top and the bottom is way more simple than this rule, because this rule can get confusing down the line. Because what you have to remember, if you're going to try to follow this rule, and that's totally fine, you always want to take the exponent in the numerator minus the exponent in the denominator. Now, this isn't confusing when my problem's like this. It's confusing when my problem's like this. Right? Because now, if I do our new rule, because we're dividing, I'm going to take my exponents and subtract them. I end up here with x cubed, right? I end up down here with x to the negative 3. Okay? And we haven't really talked about negative exponents yet. So, what you have to remember then is I'm going to take the exponents in the numerator minus the denominator, and my answer is always in the numerator, which means where?
The top.
The top, right? And this is kind of different than what we did yesterday. Because yesterday, when we were just canceling them out, wherever the bigger number was, it ended up staying in that same spot for our answer, right? So right here, we said, well, we're going to take 4 of these, and we're going to take 4 of these, so these are all gone, and x cubed stays on the bottom, and we would have 1 over x cubed. Well, this says that it's x to the negative 3rd, and the answer always goes to the top. Well, tomorrow we'll actually tell how to get rid of that thing right there. So, I don't think they would give you any of these kind today. So if you want to follow the rule, it's totally fine. You always take the top one minus the bottom one, and you'll get your answer. So you can follow the rule in division like we did in multiplication, or you can do what we did yesterday and just simplify by crossing them out. Make sense?
I found a trick.
Oh, good.
Oh.
Your other trick worked so well. No. Remember your other trick? Your other trick was, you thought was like flawless, and then we found out how many mistakes.
It's less of a trick, but it's more of a weird fact.
Okay.
You
Show
can
us.
take
Your weird
9.
fact.
Then you take your exponent on your calculator, you press that and press any number as many times as you can and make it equal, like gives you a pair. After you take 9, then you do the exponent. Then you do
Alright.
it.
We'll try it later. Let's try a couple more of these division problems. Alex, sit. So, first one, 8 to the 11th over 8 cubed. So again, just like when we were doing our multiplication ones, if I can punch it in my calculator and get a specific answer, I want to do that. So, before I use my calculator, I would have 8 to the what? 8 to the 8th, right? Because again, I'm doing 11 minus 3, or I'm thinking, all right, I'm going to take out as many as I possibly can for both. And I would have got my 8 to the 8th. So, if we punch in 8 to the 8th, what do we get?
6.
Why do you got one?
16,777,216.
Not 600. Something.
Right? What did you get 6?
I did it. You do 8.
Any questions here? So let's try another one. Everybody, again, if you need a calculator, make sure you find a calculator and know how to use the calculator. Well, I really can't see this one. M to the 6th? Is that what it says?
And to the 5th.
No, this is
Wait, which one are we
the
on?
top.
And then 4M to the what? Alright. So, again, do the numbers and then do the variables. Then we'll try one more. And try that one. Everybody get an answer?
Yeah.
First one up here, what did you come up with?
5. And
So 11. 1.
Right? Because remember, what are we doing? We're dividing, so we really subtract, right? Division, subtract, multiplication, we're going to add them. So we get 5m. Everybody agree? Again, 20 divided by 4 is my 5. M to the 6 is bigger, so it's going to be on the top. If you want to write it like that, you can always have that 1 on the bottom, but you don't need it. Okay? How about the next one? Made you think a little bit, right? What can I take out of both numbers? 36? How many times is 36 going to 144? 4. All right. So, how many do I have x's?
5.
X to the 5th. Y's.
6.
To the 6th. Z's.
3.
3. And what's on the bottom? just 1, right? So, let's just say that this number we didn't cancel out totally. You would just leave that number on the bottom, whatever you simplified it to. Okay? And there could be some variables left on the bottom also. All right? The last kind of problems look something like this. And I don't know if these numbers are right, but. So basically what this problem is showing is that now there's some parts that show multiplication and there's some that show division. So realistically, if we go back to the order of operations, which was PEMDAS, right? The M and the D had what power? The same power, right? Okay, so in a sense, we said we should always work left to right when we had N's and D's together, or multiplication and division together. Well, you can't really work left to right necessarily to do both the multiplication and division. So what I would recommend when there's a combination of both multiplication and division is to simplify on the top, simplify on the bottom, and then do your division. So I would realistically do all of the M's first. But again, you can try it different ways. So if I simplify the top, what do I get? Y to the 8th. So here you got to really kind of stop and switch gears a lot, right? Because now what am I doing? Multiplying, so I'm adding. But now I'm going to divide, so now I do what? Subtract. So I get y to the 4th. Okay? So try this one by yourself. D to the 7th. F to the 4th. All over D squared times dt. I really can't see. That's okay. We'll do it that way. So again, simplify, or you can cancel out. It doesn't really matter in this one. Everybody get an answer? So what'd you come up with?
T to the 4th. D to the 4th and F to the 4th.
D to the 4th.
F to the 4th over T, that's what I got.
All right, that's what Alex got. Anybody else get that? Are they right? So again now, what is D squared times D?
This makes me like D is D3.
This is basically D cubed, right?
Yeah.
And then we bring our T along. So now, everything on the bottom is kind of simplified. Now if I go up and down, 7 minus 3 is 4. I didn't have any F's, I didn't have any T's, so looks like we're right. Everybody agree? We need to do another one of those kind? Yeah? All right. So, K to the 8th times M to the 6th over K to the 6th times M to the 3rd times K squared times Z to the 4th. Try that one. And make it think here. So again, take your time and go in order, combining things. How do we do? Alright, so, what happens to my k's? They all cancel out, right? Because k to the 6 and k squared ends up being k to the what?
Eight.
K to the 8th. So if I have k to the 8th on the bottom and on the top, they're just going to cancel each other out. Okay? How many m's do I have left?
3.
Where are they?
Top.
On the top and z to the 4th. So we should add m cubed over z to the 4th. How do we do?
Good.
Boom. So again, the biggest part of this is to not lose anything along the way as you start scratching things out. Okay? Here's your sign. Again, this is stuff that we probably really have